Hey everyone, Chang here and welcome to my channel. This is the bare minimum algebra series, and last time I mentioned that I wanted to use the techniques, the information learned about system of equation into something better than just a very lame eyeball way of solving system of equation, right, with graphing. So let's build on that, build on our knowledge on how to graph inequalities and actually solve and graph systems of inequalities. Here it is. Amazing, right? Now, this one is very interesting, and you'll see in a second when I give you guys the example. It's technically only two very concrete steps. However, the first one might take you forever depending on how many system of or how many inequalities are in that system of inequalities, right? Because unlike a system of equation, usually they only have, for example, if you're working with two variables, they usually only have two equations. If you're working with three variables, then you have three equations, four variable, four equations, so on and so forth. System of inequalities is very different because if you recall just graphing inequalities, if you haven't seen that video, check it out, right? You're shading an entire range. So therefore you have the possibility of having multiple system of multiple inequalities with different regions that overlaps. So instead of saying that, oh, because we're working with x and y, there's only potentially two, right, inequalities, there's actually potentially it could be up to infinite if a person who's designing the problem really want to just be spiteful. So, therefore, our first step can always be reoccurring. You want to be able to graph all the inequalities that they've given you in that system of inequalities. And then finally, after you finish graphing them all, the final overlapping area is the answer to the system of inequalities. So, I think it'll make more sense if I just go over the example very quickly so that you guys can see what I mean by it being reoccurring, and then that the final shaded region is the answer. So let's just look and begin. All right, so here is our example of a system of inequalities. Notice that there are actually three entries in this case, three inequalities inside this whole system. Could be more. It might not be shaped like this, right? Please don't misunderstand that, oh, this one has x and y, this one has y only, this one has x only, and it's always going to be like that. That's not true. This one could have x and y, this one could have x and y, and this one can have x and y, and so on and so forth, right? It's a little annoying, but that is entirely feasible. I just wrote this because I don't want to go through all that trouble, and I think this one at least will prove the point of how to actually graph it without, getting bogged down with all the different math and manipulation. So these are all written out very nicely. All we have to do is graph, and you guys will notice, hopefully, that the final shaded region is that answer. The first one is very similar to the slope-intercept form, except for as an inequality, right? So we're going to draw a graph, right? I'm going to start off with our slope is 1. And we can start off at any points, right? If we put in 0, that's going to be 0, 2. So 0, 2 right here. Our slope is 1, so it's going to be 1 up, 1 over. There it is. And now, since this is a less than, right? Instead of a solid line, we're doing a dotted line. That's our first line, right? Now we have to pick a point and then shade that specific region. So I'm always going to pick the easiest one, 0, 0. 0, 0, is that true? So it's going to be 0. 0 plus 2 is 2, so 0 is less than 2. That's absolutely true. So our first one, our first equation, we're shading this area right here, right? And I don't want to shade it just so you guys can see what's going on, right? This entire area is technically shaded for this first inequality. Let's look at the second one. Why is everything greater than or equal to -1? So here is -1, right? And then this is a solid line. And then it is everything greater than or equal to, I can pick any point. I'm gonna pick 0 again because I wanted to, and it's probably really good, and that is true. So now let's just say it's gonna be shaded everything. Let's how can I shade this without it being confusing? Let's do this. Shades everything up here. Okay, notice this little area right here is overlapping. Okay, but we're not done. There's one more. There's this guy right here. X is less than 4, so we're gonna have to do 1, 2, 3, 4, eyeballing of course, right? And then this is a less than only, so it's dotted lines. Okay, I'm probably making a mess right now. All right, and then now we just got to figure out where is it shaded. I'm gonna pick 0, 0. Does that work? Yes, it does, because 0 is less than 4, so it's all of a sudden shaded this way on the other side. Let's just do. All right, so it's a little harder to see. Let me see if I can grab another color marker and make it a little more visible. But basically, here's what it is. It's everything from here to here to here. So this region here is the overlap of all three. So the answer for this system of inequality is any point that falls within this region right here. Okay? That's how you would figure out the answers for system of inequalities by graphing. There it is, right? And usually, interestingly enough, even though I hated it when it was used to solve system of equation, system of inequalities graphing is actually really good just because you can see the entire region, all the different points in there that you can pick that will make all these statements true. All right, so there you have it. That is how you solve and graph system of inequalities. Unlike system of equations, I actually do prefer graphing system of inequalities because it shows you an entire region, meaning that any points you pick within that region will satisfy the condition for all of the inequalities in that system. In case you guys, well, let's just summarize. The first step, a reoccurring step like an algorithm, right, is to graph every single inequalities that is available in that system. So you graph 1, are you done? No. Graph 2, are you done? No. Graph 3, so on. You know, it's like an if-then statement. And then from then on, after you graphed everything, you have all these different shaded regions. The second step is you want to isolate or figure out where is the final shaded area where everything overlaps. Right? In our example, there was 3 possibilities of shaded regions and graphs, and we found out afterwards that they all overlap in this little triangle right here. Every time you do a system of inequalities, it's going to be slightly different. But overall, the process is still the same. You just keep graphing until in the end you're done graphing and you find that shaded region, and then you're good to go. Anyways, there you have it. If you haven't already, please like, comment, and subscribe. I will see you in the next video.